Well, we probably thought we could count, but we're going to make life a little bit more complicated. And the point is, the reason for doing this is that we want to enumerate a finite sample space. And Berger and Casella give us this idea of a fundamental theorem of counting. And the idea is if we think about a job that consists of k tasks, and that the ith task can be done in n sub I different ways. Therefore, the entire job can be done in n sub 1 multiplied by n sub 2 multiplied by all the way through to n sub k different ways. And they go on to give a proof, certainly for k equals 2, that this fundamental theorem is correct. So for instance, if we think about multiply one possibility by n2. So we're saying I'm combining two tasks, so the first task can be done in one way, and there are n sub 2 possible ways of completing the second task. We then have to add to this one of the other possibilities for task n1 multiplied by n2, and of course we're going to have to continue this multiplication until we've added, we're going to have to continue this until we've added all n1 different possibilities, and of course this sum is just n1 multiplied by n2 when we simplify. So that's the fundamental theorem of counting, and we're basically going to use this principle in slightly different ways to deal with slightly more interesting problems.